Hello everyone, my name is Hubert and welcome to Teach Me channel. Today we'll be looking at GCSE Physics non-renewable energy. So last time, in the last video, we had a quick rundown of all these different sources of energy, and they split into renewable energy, which you can renew, which you can use forever, and non-renewable energy, which, as the name suggests, is not renewable and it will run out. And now we will look at non-renewable energy in a bit more detail. So without further ado, let's get started. Okay, so what types of energy sources constitute non-renewable energy? Well, first of all, we have coal. We can burn coal in a power station and generate electricity like that. We can burn coal to heat up water, which creates steam, which as it goes up, it turns the turbine. For the same thing, we can use oil. We can use oil in a power station, but we can also use oil to power cars directly. We can burn oil, and then the combustion of oil pushes the cylinders in the engine and makes the cars move forward. Then we have gas, natural gas. We can use it directly, as in our cookers can often be based on natural gas, which we can burn and it will release heat, or we can use it in a power station much the same way as we would use coal. And the final non-renewable energy is actually nuclear energy. Some people often call it renewable energy, but technically it is not. Nuclear energy is not renewable. It is predicted that it could last us for very, very long time, but as the principle goes, it is not renewable. The uranium, all the radioactive elements that we use in nuclear energy can potentially run out. Now, nuclear energy uses radioactive decay, where the radioactive particles decay, and that causes them to release some energy, some heat energy. And we can control that rate of decay by removing the barriers, and therefore we can control how much heat we are releasing, and we can we can heat up water, which turns to steam, which powers the turbine, which creates electricity. So those are the four main types of non-renewable energy. Now, we're going to go over some advantages and disadvantages. Now, the advantages of non-renewable energy is that it's incredibly reliable. We know that we have deposits of coal, we know we have deposits of gas, we know we have deposits of oil, we know how much we dug up, and we know that every time we will burn coal, every time we burn oil, every time we burn gas, we know exactly how much energy we're going to get. We can calculate it, and we can meet the energy demand. We know exactly how much of these things we need to meet that energy demand. And what goes with it, it is also adjustable, easily adjustable. Because if we want more energy, well, we just need to burn more coal. We just need to burn more oil or gas. If we want less energy, well, we just need to burn less. So that helps us adjust exactly how much energy we are getting to meet the current energy demand. On a slow day, we may not be burning much of these things because we don't need much. In summer, for example, when people are not heating their homes, we will be burning much less of these because their demand will be lower. However, when winter comes round and people start heating their homes, so there's a much higher demand for electricity and heat, then we need to start burning more of these to meet that demand. So that's a great advantage, this sort of adjustability of non-renewable energy. And for example, say wind farms are an example of renewable energy that is not adjustable, because It just depends on wind. If you get a lot of wind, you get a lot of energy. If you get no wind, you get no energy. Whereas here, we can adjust exactly how much of non-renewables we need to burn in order to meet the energy demand. Also, non-renewable energy is very cost effective. While the initial setup costs may be quite high, the running costs are actually quite cheap. Because these materials, the raw resources that we use, are quite cheap. In case of nuclear energy, they last us a long time. So non-renewable energy tends to be cost effective, which is why currently it is our go-to energy source, because it just makes business sense. If you have a power station, it just makes a good business sense to use these non-renewables, because the running costs are cheaper than many types of renewable energy. Now, however, despite these pros, non-renewable energy, as you probably already know, has its disadvantages. The first one is that it's finite. The earth coal will run out, the oil will run out, the gas will run out someday. Someday these raw resources required for non-renewable energy will run out, hence the name, non-renewable. So that's a very, very major disadvantage, and that's one of the big reasons why renewable energy is becoming more and more important as we go on. The non-renewable energy has high setup costs compared to some of the renewable energy types. I mean, because you need to set up an entire power station, you need to make a massive building with lots of technology tools in order to be able to even extract that energy on a large scale. So the setup costs can be high. However, it's still cost effective due to lower running costs and due to big output of energy by these raw resources. And then the third disadvantage is, of course, as you probably know, environmental issues. Non-renewables contain many harmful chemicals, starting with carbon dioxide, which can harm environment. So environmental problems are a major disadvantage for non-renewables. It also can be a problem for renewable energy, but non-renewable energy is the major culprit for the current environmental problems. Now, let's look into those environmental problems. Let's see what they are. 1 second. There we go. Okay. So I prepared a little diagram that outlines all these environmental problems. So how about we start off with the obvious one here. We will start here. Okay. So burning non-renewable resources, the fossil fuels, I'm not talking about nuclear fuel here, burning fossil fuels such as coal, gas or oil ends up in releasing carbon dioxide, CO2. And carbon dioxide is the important culprit in global warming. It is very important culprit in global warming because of I'm not going to explain it today, but because of the reactions it undergoes higher up in atmosphere, and also how it reflects the light. So essentially, carbon dioxide leads to a situation where the light from the sun can get through the Earth atmosphere, can get to us. However, it cannot get out. It just bounces off back down. So that heat does not get out. The heat can get in, but it cannot get out. And that's why it's called a greenhouse effect often, because like a greenhouse, the light and the heat energy gets in, however it cannot get out of that greenhouse. So that's the major problem with using fossil fuels as a source of energy. Now, another problem is specific to oil, which can be, that it leads to oil spillages. I mean, probably the most recent major oil spillage catastrophe was the BP one a couple of years back. And So some of you may have even experienced the horrific effect it can have on the ecosystem and on the aquatic life. I mean, it can kill birds, it can kill the birds that live near the sea, it kills fish. I mean, the whole point of oil is that it took ages to form, so therefore it doesn't decay, it doesn't go away that easily. It's there to stay. And as you probably know, you can't really drink it. It's quite harmful for you too. So that can become a big problem because that oil just doesn't go anywhere, and you need to manually find it all and clean it all up. And that's a major operation, and it's a big difficulty. Also, another issue is landscape damage. For example, coal mining can cause quite a big landscape damage, especially if you have a sort of open air coal mines where you literally just dig into earth, and you essentially dig through a large area. So it can be quite unsightly, and usually you have lots of smoke coming from such an area, so it can cause considerable landscape damage. Another fossil fuel associated problem is sulfur dioxide. Many burning fossil fuels tend to release sulfur dioxide, which reacts higher up in atmosphere. It reacts to produce acid, and then that acid falls as rain, causing acid rain. Now, acid rain is unlikely to be strong enough to harm humans directly. It can, however, harm environment really badly. It's really bad for plants, and acid rain in past has wiped out entire forests. So it is incredibly bad for environment. It can harm plants, and as you can see, this can lead to further damage to environment because you destroy the trees, which means that those trees are not sucking up the carbon dioxide, so you're making this problem worse, and so on. So it can have big knock-on effects, so that is a big problem. Fortunately, we have filters that can filter most of that sulfur dioxide out from, say, factories, before it even gets out into the air. But if it does, it is a big problem. So those are the sort of major problems to do with fossil fuels. However, nuclear energy is also a non-renewable with a potential to damage environment, but it works slightly differently, so it has different problems. Normally when you run a nuclear power station, it actually is pretty clean. It actually is pretty clean because it just relies on the decay of radioactive materials. So it doesn't produce carbon dioxide, it doesn't really produce sulfur dioxide, it doesn't produce these harmful chemicals, it doesn't really cause oil spillages because there is no oil involved. So it is actually pretty clean, provided it's run correctly. However, if something goes wrong, as for example it did in Japan, in Fukushima during the tsunami, then things can go really wrong. Then there can be widespread environmental damage because that radioactivity, those radioactive materials, can no longer be contained. Also, explosions can happen if the whole chain reaction gets out of control. So there can be widespread environmental damages and dangers if the nuclear power station, if something happens, if something goes wrong. However, on a day-to-day basis, there is a problem of nuclear waste, because after the power station is done with those nuclear radioactive materials, they still are highly radioactive. They're just not radioactive enough to be efficiently used in the power station. However, they are still highly radioactive, so it is very hard to dispose them in a safe way that does not damage the environment. So that is, of course, another environmental problem that is posed specifically by nuclear energy. So this is it, guys, for today. We covered some pros, we covered some what non-renewable energy is, we covered some pros of it, why we use it today, and we also covered some disadvantages with also focus on environmental problems. Okay, so thank you very much for watching. I really appreciate it, guys, every time you watch. If you want to see more daily videos on sciences, maths and biomedical sciences, hit that subscribe button below. If you like this video, give me a big thumbs up. Thank you again and see you next time.